Welcome to Miss Taylor's class videos, and today we're going to talk about our Hinge theorem and just kind of remember our triangle inequality theorem. So we talked about our inequality theorem before Christmas. The sum of the lengths of any two sides must be greater than the third side. So if we have sides of 3 and 5, we can write an inequality to figure out what the smallest that third side could be to what the biggest that third side could be. So the first thing we're going to do is we're going to take the 3 and the 5 and we're going to add them, and that's going to be our biggest number. Then we're going to take the 3 and 5 and subtract them, and that's going to be our smallest number. So that third side could be anywhere between 2 and 8. Our longer side and our longer angle theorem, they go together and they describe the same thing. So remember that if we're talking about I'm just going to draw an obtuse triangle to make it easier to understand. If this is our biggest angle, we know the side opposite is the biggest side. If this is our biggest side, we know the angle opposite is our biggest angle. Same thing for if this is the smallest angle, that would be the smallest side, so on and so forth. And so now we're going to get to what we, words are not coming easy today. So now we're going to talk about our Hinge theorem. So our Hinge theorem says that if two sides of a triangle are congruent and the included angle of one is larger than the other, then that side is larger than the other. So for our Hinge theorem, we need two sides to be congruent. Two sets of sides to be congruent, and then we need one set of angles given. So if we look here, Vx is congruent to RT. VW is congruent to RS. And then we have the angles where those two sides meet. So we notice that angle V is greater than angle R. So if angle V is greater than angle R, then XW is going to be greater than ST. We can also write this as ST is less than WX. Both of these are the exact same thing. And that's all that Hinge theorem tells us. The bigger angle is opposite the bigger side. The smaller angle is opposite the smaller side. So the converse of the Hinge theorem gives us two congruent sides, and then it gives us one set of sides. So when we talk about two congruent sides, we're looking at CB and FE. We're looking at AC and DF, and then they're going to give us the measure of the third side. So that's going to tell us to look at the included angle right here. The bigger the side, the bigger the angle. The smaller the side, the smaller the angle. So again, the measure of angle C is greater than the measure of angle F, or the measure of angle F is less than the measure of angle C. Both of these statements are true. So we are looking for two sets of congruent sides. So I have one set of congruent sides here, but nothing else on this triangle is marked. So we have to remember that we have what we call our reflexive property. So we know that PS is congruent to PS because of the reflexive property. So we now have two sets of congruent sides, and they gave us the third set of sides. So because they gave us the third set of sides, we're going to use the converse of the Hinge theorem. So we're looking at our included angles. We're looking at these angles right here. So PT is greater than RS. So I know that angle PS, let's make that actually look like a P. PST is going to be greater than angle RPS. And again, we can always write it the opposite way. Angle RPS is less than angle PST. So here we're looking for two sets of congruent sides. So we got one set right there. And then because of our reflexive property, we know that Km is congruent to Km. And then they gave us two angles. So if they gave us two angles, that means we're using the Hinge theorem. I know that 64 is greater than 61, so I know that Jm is greater than Ml, or Ml is less than Jm. And that's how we use the Hinge theorem. All right, so we can use Hinge theorem to write proofs about triangles. So let's first and foremost write down our given. Oh, come on. And that's our given. So we need to remember to use Hinge theorem, we need two congruent sides, and then we either need one set of angles or one set of sides. So they gave us that two angles are congruent, but that doesn't necessarily help us unless it gives us other information. So let's look at angle XWY and angle XYW. So I notice that I've got a triangle right here. And I remember that if I have two angles that are congruent, especially if they're the base angles, then I know that the two sides are congruent. So the reason I know that is because that means that triangle XWY is an isosceles triangle. And if it's an isosceles triangle, I'm going to use either my base angles theorems, which tells me that my sides I start with congruent sides, or it's going to be my converse, which means I have congruent angles. So since we started with congruent angles, it's going to be the converse of base angles theorem. And so if I know that that's an isosceles triangle, then the next thing that I know is that XW is congruent to XY. And again, that's our definition of isosceles triangles. So I have one set of congruent sides. So we have congruent sides. I need to find another set of congruent sides. Now, real quickly, I'm going to highlight some things and see if I can figure out where my next step needs to be. So I've got WXZ, which is this angle here. So that means we're going to have to be talking about this as a triangle. And then I've got YXZ, which is this angle here, which means that this is the triangle that we're talking about. I just said that that's congruent to that. Ooh, I just noticed what I'm going to put next. They share the same side. They both have XZ. So I know that XZ is congruent to XZ because of our reflexive property. So now I've got two sets of congruent sides. Now I either need a set of sides or a set of angles. So we've used this information here. We haven't used this information here. So let's look at that information right there. So WZ is greater than YZ. So if WZ is greater than YZ, which is already part of my given, that's my set of sides. If it's my set of sides, I need to use the converse. And I have enough information because we have a set of sides in the given. We have two sets of congruent sides, so we are ready to prove this. So the measure of angle WXZ is greater than the measure of angle YXZ. So by the converse of Hinge theorem.